Hello, hello. Welcome back to the lab. So if you are picking up right where we left off, that means that you just saw us not rush at all and definitely did not blow up a battery daughter card. Yeah, so what we just did is we were running battery daughter card at about, well, it was no load, but 250 volts DC. That's where we left off. And so we tried to hook the inverter up to the output of the battery daughter card, and then kaboom, there was a flash, there was a bang. Now she doesn't work. Okay. It's a little concerning. Nothing that we can't navigate, but it's a little concerning. And so, I guess, yeah, we saw a little bit of smoke leave, but we didn't see much outside of that. And now this is just an inkling, based on the fact that I've already done some debug, but I have a feeling that this fuse that went nuclear might have something to do about it. Actually, let's switch over to the microscope. Let's see if I can get this under there. Yeah, see that giant skid mark where a fuse is supposed to be? Yeah, the fusible link has indeed blown. So that tells me that we pulled more than 2 amps from the battery daughter card. Okay. Using some very basic deductive reasoning, well, if we pulled more than 2 amps from the battery daughter card, we know that it probably wasn't the charger, because the charger is, well, it's current limited. We can't push more than 2 amps through the charger. And also, we know those batteries are pretty much fully charged. So if those batteries are pretty much fully charged, that means the charger wouldn't be pushing a whole lot of current through it. That doesn't really make sense. Okay. There's a 24 volt backup, which, I mean, the current consumption wouldn't have really been that much more on the 24 volt rail, which leads us to the last option, which is the H-bridge made of FETs. So before we do too much debug, let's just see if any of these FETs may have failed short. I've got the schematic here. Never mind static control. This just plop this piece of paper on top. Sorry, just mocking myself. So from pin 3 to pin 2, so positive on pin 3, negative on pin 2, we should measure a diode drop. It looks like 2 of our transistors have failed short. Come on now. Which transistors are those? Of course I put the ref des under the part. That looks like Q204 and Q202. If I had to guess, those are probably the high side FETs. Q202 and 204. No, those are the low side FETs. Whoa. Okay, so this could be a dead time programming issue. It was probably some shoot through, but for some reason, those FETs bit the dust first. Sorry, that was super out of focus. That's probably a little better. Sorry about that. Okay, that is super interesting. Well, at least to me. So this will add just a little more dead time. That'll give us a little more timing margin, so if it was a shoot-through situation, as things change a bit, specifically with higher voltages, as voltages get higher, the parasitic capacitance is inside the FET, we'll start to fight the gate driver, and maybe we cut it a little too close. So slowing things down a little might hurt our efficiency a touch. But it should also help us to evaluate the situation a little better. We should be pretty well coupled to low voltage DC. There should be pretty much nothing on the high voltage bus by way of loads or otherwise. There should be no short circuits. And because of the way this is configured, once we hook up the battery, it should just kind of take off. Oh, yeah, fuse might help. Fuse might help. Forgot we gotta change the fuse. We're gonna run out of 2 amp fuses. But it seems like the 2 amp fuses are protecting everything downstream. So at least there's that. Ah. There she is. Trying to make it so you guys can see the display. That is proving very difficult. Charger seems fine, though it is in current limit because we're trying to backfeed a DC power supply. Yup, that's a thing. Don't do that. That's a bad idea. Excuse me one moment while I get to that daughter card. Oh, come on. You're killing me. We're in daughter card 2. Alright, voltage out, 32. Yep, good. Just high enough that it's not disabling. Safety squints. There we go. Duh! Okay, so that was fine. We didn't just blow up. What you just saw was it detecting that the battery voltage was too low, and then it switched itself off. Congratulations. The UPS does something. It detected that the battery voltage was too low, and it turned itself off. In the brief moment before it did that, we saw a waveform. But we didn't see it quite long enough. Okay. Let's, look at that. Let's run a little more. Okay. So I believe we're generating high voltage. That's pretty cool. Daughter card is still running. At least, I believe we're generating high voltage. Okay, let's try that one more time. So it seems fine. I'm not really seeing anything that would indicate this should blow up. Not really seeing anything bad at all. Let's hook up the other daughter card and try it with more dead time. Yeah. Why not? Come on now. Is that fully seated? Yeah, it is. Okay. So we've got our mains output. It's like we're not really going to see it unless we have the scope on it. So we're just gonna have to get the scope on it. I'm not sure if you can see the D and M, but that's okay. Got it set to AC volts. Yep, you can see that just fine. We're at 0. 2 amp on the input, but we got a much lower current limit and a lower operating voltage. So, dope. That's not what I wanted to do. Looks like we're pretty much ready to go. Lower current limit. Let's see what happens. Okay. We hit the current limit. Now we're off. I think we might have hit the current limit, and then it detected the under voltage, and then it turned off. What I'm hoping is that was a soft enough fault that we didn't blow up our FETs again. That is my hope. Because I really, really, really don't want to keep replacing these FETs. That's the truth. And if it did blow up our FETs again, that means that we are super out of bounds for the safe operating area of these, and I need to get some better FETs on order. Because we just reduced the voltage by about a factor of 2. That should have been okay. So let's just go into ohm check mode. Let's check for a short on pin 2 and 3. Hey, it looks like our FETs might have survived. Okay, it looks like our FETs might have survived. That's awesome. Checking that the low voltage or the high voltage has been resolved. Let's pull this daughter card back out. Pull this daughter card back out and let's get her powered back on. Step 1, give her some DC, wait for the click. Step 2, powered on from the battery module. Let's see if we can kick this thing into gear without killing it. Yep, looks like our high voltage DC bus still operating. Excellent. So we didn't blow up the card. Okay. So I am gonna put the scope in single mode. We're gonna put the horizontal trigger point to the left a bit. And we're gonna try to capture this transient because that's about all we can do. I need to figure out why this thing keeps blowing up. And the switch node should tell us if it's shoot through the gate drive signals. Should give us a hint. We just gotta get to the bottom of this. Maybe there's a soft start that we can, maybe there's gotta be something that we can do to make this happen in a better way. 3, 2, 1. Okay, what are we seeing? That looks fine. Nothing looks wrong with those switching waveforms. There is a little bit of shoot through, I will give it that. A little bit of shoot through. But I've got a feeling we might have actually survived and we might have actually hit the current limit. So before we go and give up on this, Here's the click. Let's give her just a little more current. Let's see what we can do. Okay. Single mode active. Did we actually generate a sine wave? I wasn't watching. I have no idea. I have no idea if we generated a sine wave or not. Now it's possible that we violated the safe operating area of all of the FETs in that first explosion. And it's possible that we've got a dead short on the DC bus now. That would really be a shame. But hey, at least we didn't power off this time. Small positives. Small positives. Alright, let's check. Home check on the high voltage bus. Dope. So, that would explain why we blew up our FETs the second time on the DC link. Check, let's make sure the battery daughter card is still alive. Yep, we're still able to generate high voltage DC. Awesome. Okay. This tells us more. I think I'm gonna have to leave this episode here. Thank you guys so much for watching. First time we blew up this battery daughter card. Might have had something to do with the safe operating area. Might have had something to do with the short on the secondary side output. Might have had something to do with shoot through on this daughter card. Now that we were switching at, 250 volts DC instead of a measly 60. So maybe we'll have to tweak the feedback network on this daughter card, decrease the output voltage a little bit, increase the dead time on these FETs a little bit to accommodate for the longer, or the more current coming through the parasitic capacitances, but dang. We're still kicking. We're still kicking. Another little mini deep dive we're gonna have to do is figuring out why the heck this Arduino Mega keeps dying. Like whenever we enable one of our daughter cards, it just immediately goes out to lunch. It is like, nope, I'm not helping you there. Nothing to do about that. Nope, no more monitoring for you. I've noticed it's a little picky about resets. It's possible that we're giving it a little bit of a reset glitch. Maybe need a stronger pull-up on that reset line. Not exactly sure. I think we're gonna have a couple days of debug with our DC power supply feeding energy in. Still need to get some proper clips for the TO220s. Maybe some new FETs here. Maybe some new FETs for the inverter. But thank you all so much for watching. Thank you to those who have subscribed on Patreon. Really appreciate your support, both through watching the videos and by chipping a buck in the hat. You guys are awesome. Most of all, I hope that you learned something great today, and I hope to see you again soon. So thanks for watching EEforEveryone, and thank you for staying till the end. Bye!